Hi students, myself Kale SL, Rayat Shikshan Sanstha, RBNB College Rampur. 11 Science Mathematics Part 2, Lecture number 4. Chapter number 1, Complex Numbers, Exercise 1.1. In the previous video lecture, we have completed here question from 1st to 10, and today we start here question number 11. Now here we have seen the powers of I. Here I is equal to, we know I is equal to under root of minus 1. Then I square is equal to square, we get it as a minus 1. I cube is equal to, we know it as I square into I square is minus 1, so minus I. And I to the power 4, it is equal to 1. These are the powers of I. Also, if there is a complex number a plus ib or a plus bi, its conjugate is a minus ib. We change the sign of imaginary number, then we get the conjugate of complex number. Now these are the basic parts of complex number. Now let us try to solve example number 11. Here find the value of 1 plus I square plus I to the power 4 plus I to the power 6 plus I to the power 8 plus up to dot dot I to the power 20. So solution of this, consider or let here 1 plus I square plus I to the power 4 plus I to the power 6 plus I to the power 8 plus write all the terms up to I to the power 20. So here we write I to the power 10. There is difference of power is 2. So here 2, 4, 6, 8, 10. Then take here plus I to the power 12. Then I to the power 14. I to the power here 16, I to the power 18, and I to the power 20. We have to find the value of this. So this is equal to here 1 as it is plus I square, we know it is minus 1. I square is minus 1 plus I to the power 4, it is 1. We have seen the powers of I. Now here the powers higher than 4, we divide that number by 4 and we write like this. Plus I to the power 6 as I to the power 4 into I square. Here we take 4 plus 2, that is 6. Then here I to the power 8, we write I to the power 4 to the power 2, 4 to the 8. Now here I to the power 10, we write I to the power 4, divide this 10 by 4, 4 to the 8, 4 to the 8, and remainder is 2. So write that as a separate power of I, that is I square. So 4 to the 8 plus 2, it is 10. Now here I square, right here I to the power 4 to the power 3, 4 3 the 12. Then here I to the power 4, here 14. So divide by 4, 4 3 the 12, and remainder is 2. So we write it as a I square. Plus here I to the power 16, we write I to the power 4, divide this 16 by 4, 4 4 the 16, plus here I to the power 18, divide this 18 by 4, we get I to the power 4 to the power 4 4 the 16 and I square. Plus here lastly this I to the power 20, we write I to the power 4 to the power 5, 4 5 is 20. And we know that here I to the power 4 is 1, I square is minus 1, put the values. So we get here, we cancel this plus 1 and minus 1. So it is equal to this 1 as it is, plus here I to the power 4, it is 1, I square is minus 1, plus here I to the power 4 is 1, it's a square. Plus here I to the power 4 is 1, its square, I square is here minus 1, plus here I to the power 4, 1, its power 3, again here I square is minus 1, plus I to the power 4 is 1 to the power 4, plus here I to the power 4 is 1, its power 4, and I square is minus 1, plus here I to the power 4 and its power is 5. 1 to the power anything that is equal to 1. So we get here 1 plus minus, that is minus 1. Here 1 square is plus 1. Here 1 square is 1 into minus 1, that is minus 1. Now here plus 1 cube into minus 1, that is minus 1, minus 1. Here we get this 1 as it is. Now this I to the power 4 into I square, I to the power 4 into I square. We check again here, this 1 and minus 1 get cancelled. Here 1 as it is, we write again this 1 as it is, then 1 minus 1, then this 1 to the power square. Here 1 to the power square into minus 1. Here 1 to the power 3, not here minus 1. Now see here, 1 to the power 3 plus here 1 to the power 3 and I square is minus 1, plus here 1 to the power 4 and plus here 1 to the power 4 into I square is minus 1, plus here 1 to the power 5. And now here this 1, now plus 1 into minus 1 minus 1, plus 1 here 1 square 1 into minus 1 minus 1, and this plus 1. Now here next plus 1 cube is 1 into minus 1, that is minus 1. Here it is minus 1. Now this term plus 1 to the power 4 1. Now this term 1 to the power 4 is 1 into minus 1, it is minus 1, and last term 1 to the power 5 is 1. Now this plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 minus 1 get cancelled. Every term get cancelled, only 1 remains here, and so it is equal to 1. So the value of this problem is 1. Hence lastly we write here, hence therefore 1 plus I square plus I to the power 4 plus I to the power 6 plus up to dot dot plus I to the power 20, it is equal to 1. Now here in this way we have completed this 11th problem. Now we see 12th problem. 12th problem, show that 1 plus I to the power 10, 1 plus I to the power 10 plus I to the power 100 plus I to the power 1000, it is equal to 0. We have to show this. Now we consider here left side. So consider here LHS. LHS is equal to 1 plus I to the power 10 plus I to the power 100 plus I to the power 1000. And now we find the value of this. So this is equal to 1 plus we write this I to the power, we divide this 10 by 4. So firstly write here I to the power 4 and divide to 10. So 4 2s are 8, remainder is 2. So write separately I square, that is 4 2s are 8 plus 2 10. Similarly here we write I to the power 4 and here 4 2s are 8, then 2 and 0, that is 20, and 4 5s are 20, 4 5s are 20. Then here plus, here also we write I to the power 4 firstly, that means divide this 1000 by 4. So here 4 2s are 8, 2 and 0 20, 4 5s are 20 and 0 as it is, that is 250 into 4, that is 1000. And therefore here we get 1 plus I to the power 4, that is 1, so 1 square, I square is minus 1 plus I to the power 4 is 1, 1 to the power 25 plus I to the power 4 is 1, 1 to the power 250, 1 to the power anything, that is equal to 1. And therefore we get here 1, here 1 square 1 into minus 1, that is minus 1, here plus 1 and here also plus 1. So we get here in the problem here it is minus, in the problem here it is minus. So take here minus sign, here minus sign, here minus sign, and here also minus sign. So this is minus. Now this minus 1 and plus 1 get cancelled, here minus 1 and plus 1 get cancelled, so it is equal to 0, and which is nothing but the RHS. Hence proved. Hence proved. So we have completed this 12th problem. Now 13th problem we see here. 13th problem, question number 13 is 1 plus I to the power 14, 1 plus I to the power 14 plus I to the power 18 plus I to the power 22 is a real number, is a real number. Justify. Now see here, we have to justify whether this given problem is a real number or not. So when it is a real number, the term of I is not present here. So in the answer, if there is a I, then it is not real number. So we solve this. Consider here, consider 1 plus I to the power 14 plus I to the power 18 plus I to the power 22. So it is equal to 1 plus here I to the power 4, divide this 14 by 4, 4 3s are 12, 4 3s are 12, 12 and 2 14. So we write here I square. Then again here I to the power 18. So we write firstly I to the power 4 and divide this 18 by 4. 4 4s are 16 and I square. Again here I to the power 4 to the power 5. 4 5s are 20 and I square. So we get here 1 plus I to the power 4, we know it is 1. So 1 to the power 3. I square is here minus 1. Plus here I to the power 4 is 1. So 1 to the power 4 into I square, again here minus 1. Plus here I to the power 4 is 1, 1 to the power 5, I square minus 1. And so we get here 1 cube is 1 into minus 1, that is minus 1. Here again 1 into minus 1, minus 1. Here again 1 into minus 1, minus 1. Here plus 1 and minus 1 get cancelled. So the answer is minus 1, minus 2. Answer is minus 2. In this minus 2 there is no I. So it is a real number. Which is a real number? Which is a real number. So lastly we write hence 1 plus I to the power 14 plus I to the power 18 plus I to the power 22 is a real number. Now we see next problem, problem number 14. Evaluate, problem question 14. Evaluate I to the power 37, I to the power 37 plus 1 upon I to the power 67, 1 upon I to the power 67. We have to evaluate, means we have to find the value of this. So solution of this, consider I to the power 37 plus 1 upon I to the power 67. So this is equal to I to the power, we write firstly 4, divide by 4. So I to the power 4, 4 9s are 36, 4 9s are 36, 36 and 1 7. So I to the power 1, I to the power 1. So there is no need to write here 1. Now here plus 1 upon I to the power 4 and divide this 67 by 4. So 4 1s are 4. 4 and 2, 6 and 7, 27. So divide 4 by 27. So 4 7s are 28 and 4 6s are 24. 4 6s are 24. 24 and 3 27. So we write here I to the power 3. Get it? So it is equal to, now here I to the power 4 is 1. So 1 to the power 9 into I plus here 1 upon here I to the power 4 is 1, then 1 to the power 16 and I cube we know it is minus I cube is minus I. So here 1 to the power 9 is 1, 1 into I, that is I. Now this plus and minus become minus and here 1 upon I, 1 to the power 16, 1 into I, that is I. Now take here subtraction, so this is equal to, it is equal to I into I, that is I square, minus this 1, here denominator is 1, we take here product of this minus product of this divided by product of this. So here I into I square minus 1 divided by denominator of here, denominator of I is here 1 into I, that is I. So I square is again here minus 1, here minus 1 divided by I. So minus 2 upon I, minus 2 upon I. When there is I in the denominator, we have to remove this I. We multiply to numerator and denominator by conjugate. But here multiply by I. If we multiply by I, then also we can remove I from the denominator. So we get here minus 2 into I, that is minus 2I divided by I into I square. Now I square is minus 1. So we get here minus 2I divided by minus 1. Minus minus get cancelled. So we get 2I. Solution here 2I. So the in answer we have given solution here 0. But the solution here 2I, so the answer in the book is incorrect, because in the old syllabus we have given here I to the power 31. If we take here I to the power 31, then we get the solution as a 0. Now here 15th problem, question number 15. Prove that 1 plus I to the power 4, 1 plus I to the power 4 into 1 plus 1 upon I, 1 plus 1 upon I to the power 4 is equal to 16. We have to prove this. So we consider firstly left side and we solve it. If the answer is 16, then it is proved. So consider here LHS. LHS is equal to 1 plus I to the power 4 into 1 plus 1 upon I to the power 4. Now we know that using the rule of indices, A to the power m into B to the power m, we write it as AB to the power m. AB to the power m. Using same formula, here we write this as 1 plus I into 1 plus 1 upon I and whole power as a 4. Get it? Now here, so this is equal to 1 plus I as it is, and here 1 into I plus 1 divided by I and power is 4. So it is equal to, now this 1 plus I and this also 1 plus I plus 1 and 1 plus I same. So 1 plus I repeats. So we write here 1 plus I to the power 2 and divided by I and to the power 4. Now we expand this 1 plus I bracket square, and so we get here 1 square is 1 using the formula A plus B bracket square. So A square, that is 1 square 1, plus 2 into 1 into I, that is 2I, plus I square and divided by here I and then power 4. Now here I square is minus 1. We put the value of I square as a minus 1. So we get it is equal to 1 plus 2I, and here write I square as minus 1. So minus 1 divided by I and to the power 4. This plus 1 and minus 1 get cancelled, and so we get here 2 to the power 4, this 2 to the power 4 into I to the power 4 divided by I to the power 4. We put I to the power 4 as a 1, or we may cancel I to the power 4 and I to the power 4. So it is equal to 2 to the power 4, and 2 to the power 4 it is nothing but 16. 2 into 2 into 2. We take the product of 2 4 times. So we get here it as a 16. It is nothing but RHS. Hence proved. Now next we see here 16th problem. Question number 16. Evaluate I to the power 6 plus I to the power 7 plus I to the power 8 plus I to the power 9 I to the power 9 divided by I square plus I to the power 3. I square plus I to the power 3. We have to evaluate means we have to find the value of this. Consider here I to the power 6 plus I to the power 7 plus I to the power 8 plus I to the power 9 divided by I square plus I to the power 3. So this is equal to, now here in the numerator I to the power 6, I to the power 7, I to the power 8, I to the power 9. So lower power is 6. So we take here I to the power 6 common. Here also I to the power 6, here also I to the power 6, here also I to the power 6. So we take I to the power 6 common, and therefore we get I to the power 6 in the bracket. Here it remains 1. Here I, here 6 and 2 8, so I square. Here 6 and 3 9, so I cube, and divided by this I square is minus 1 and plus I cube is minus I, plus and then I cube is minus I, so plus minus become minus. Now firstly we find what is the value of this. So we get here I to the power 6 as it is in the bracket, 1 as it is plus I as it is, I square is minus 1 and I cube is minus I, so minus plus become minus, so minus I, and divided by this minus 1 into minus I. Now see here in this bracket plus 1 and minus 1 get cancelled, plus I and minus I get cancelled, everything get cancelled, so it is 0. So we get here I to the power 6 into 0 and divided by this minus 1 minus I, means 0 upon minus 1 minus I, and 0 upon anything that is equal to 0. So the value of this is 0. So in this way we have completed here 16th problem. Now problem number 17. If A is equal to, if A is equal to minus 1 plus root 3I upon 2, minus 1 plus root 3I upon 2, B is equal to minus 1, B is equal to minus 1 minus root 3I upon 2, then show that A square is equal to B, A square is equal to B, and B square is equal to A. We have to show this. Now see here, A is given minus 1 plus root 3I divided by 2, and B is given minus 1 minus root 3I divided by 2. Here root 3I is the imaginary number. Here also same imaginary number root 3I. Here plus sign and here minus sign. So these A and B are conjugates of each other. A and B, these are conjugates of each other. Now we have to show that the square of one is other. The square of first is second and square of second is first. We prove here first part, that is A square is equal to B, and there is homework to you, show B square is equal to A. So firstly we consider here A square. Let A square is equal to, A is given here minus 1 plus root 3I divided by 2 and its square. Now numerator upon denominator square, so numerator square upon denominator square, so it is equal to minus 1 plus root 3I bracket square divided by 2 square, right, directly 4, 2 square is 4. Now here A plus B bracket square. What is A plus B bracket square? A plus B bracket square is equal to A square plus twice AB plus B square. We know this formula. So it is equal to A means minus 1. So minus 1 square plus 2 into a is minus 1 into b is root 3i, and plus b square, that is root 3i its square, and divided by here 4. So it is equal to, now minus 1 square, that is plus 1. Here plus minus become minus 2 into 1, that is 2, and this root 3 into I. Plus here root 3 square. Root 3 square it is 3i. Root 3, that is root 3 square 3, and I square, divided by this 4. So it is equal to this 1 as it is, 1 minus, see here this 1 as it is, minus 2 into root 3i, minus 2 into root 3i. Now here plus, but here I square is minus 1, we know I square minus 1. So minus 1 into plus, so minus 3 divided by 4. Get it? Since here I square is minus 1. So it is equal to, now this 1 and minus 3. 1 minus 3, that is 3 minus 1, it is 2, but 3 is minus, so minus 2 and minus 2 root 3i divided by 4. Now we take 2 common from the numerator. So it is equal to 2 in the bracket minus 2 minus root 3i. Here we take 2 common, so here 1. Here it is 1. 1 minus root 3i divided by 4. Now 2 1s are 2, 2 2s are 4. And therefore we get here minus 1 minus root 3i and divided by 2, which is nothing but here b. This is b. So it is equal to b. Hence we shown here a square is equal to b. Hence a square is equal to b. Similarly we can show that, we can show that b square is equal to a. It is homework to you. So in this way we have completed here 17th problem. Now here next problem, 18th problem. Now problem number 18th and problem number here 23 are same. Problem 18, question number here 18. If x plus iy is equal to a plus ib to the power 3, a plus ib to the power 3, show that x upon a plus y upon b is equal to 4 in the bracket a square minus b square. 4 in the bracket a square minus b square. This is the 18th problem. And question number 23 is same. Question number 23 here. If x plus iy cube, if x plus iy cube is equal to y plus vi, y plus vi, show that y upon x plus v upon y upon x plus v upon y is equal to here 4 in the bracket x square minus y square. 4 in the bracket x square minus y square. See here the question 18th and 23rd are same. We solve here 18th and you solve yourself 23rd problem. So solution of 18. Solution of 18th problem. Now we have given here x plus iy is equal to a plus ib. X plus iy, that is equal to a plus ib to the power 3. Now here a plus ib to the power 3 means we use here a plus b to the power 3. What is the formula for a plus b to the power 3? That is equal to a cube plus 3a square into b plus 3ab square plus b cube. Using same formula here we expand this, and therefore we get here x plus iy. Here x plus iy, there is no need to write here a round bracket. We remove this round bracket. So x plus iy is equal to here now a cube. So a cube plus 3 this a square into b as it is ib plus 3 this a as it is now the square of ib, that is I square b square, and plus b cube. B means this, so I cube into b cube. We use this formula. So we get here x plus iy is equal to this a cube as it is plus this 3a square b into this I. Now here I square is minus 1, so plus 3ab square into minus 1, this I square is minus 1 plus this I cube is minus I cube is minus I, and b cube as it is. So we get here x plus iy is equal to, now here this a cube as it is, and now here in this term there is no I, so we write this term firstly. This plus and minus become minus 3ab square. A cube real part and this is also real part, ab square. Here plus minus minus. Now the terms of I, here this is one term and this is another term. So we write here, we take I common, so 3a square b, and here take I common and plus minus become minus and b cube into I. Get it? We take I common from these two terms. The coefficient of I is 3a square b. Here coefficient of I is minus b cube into I. And we make this as a round bracket like this. Now see here, this is the real part. And coefficient of I is the imaginary part. Means this is the imaginary number. Here also imaginary number. So comparing real parts and imaginary parts on both sides. Comparing real and imaginary parts on both sides, and therefore we get here x is equal to, here real part x, so x is equal to here real part a cube minus 3ab square. Get it? Now here imaginary part means coefficient of I, here y is equal to, here coefficient of I 3a square b minus b cube. Now observe here a cube, here a, so we take a common. So x is equal to a in the bracket here a square and minus 3b square. Get it? Now here we take b common. So y is equal to b in the bracket 3a square minus b square. Now we carry this a to the left side. Here carry b to the left side. And therefore we get here so we get, when we carry this a to the left side and b to the left side, x upon a is equal to, we get a square minus 3b square, a square minus 3b square, x upon a square minus 3b square. Carry this b, so y upon b, and y upon b is equal to 3a square minus b square, 3a square minus b square. Now here we consider this part. x plus iy is equal to a plus ib to the power 3. We consider this, we solve this, then we get the value of x upon a and y upon b. Then we have to show that this is equal to right hand side. So we consider this x upon a plus y upon b. Consider x upon a plus y upon b is equal to, put the value of x upon a, that is a square minus 3b square, a square minus 3b square plus this y upon b, put the value of y upon b, that is 3a square minus b square, and so it is equal to, now this a square and plus 3a square, 1 plus 3, that is 4a square. Now this minus 3b square minus b square minus 4b square. Now take here 4 common, so 4 in the bracket a square minus b square, and we have to show here 4 in the bracket a square minus b square. Hence proved. Hence proved. So in this way we have completed here 18th problem and solved 23rd problem using the same procedure of 18th problem. So we complete here 18th and 23rd problem simultaneously. So remaining problem we will see in the next video lecture. We stop here. Thank you.